Here's an example of a t-test. Remember, t-tests are used for scoring two groups. So we're going to assume in this situation we have group 1 and group 2, and we want to know if there's a difference between these two groups on some dependent variable like test scores for third grade math. So we need scores for each, and of course we calculate some data from those. So what I've done is I've run this test, and this is the output for a t-test. And up here we have group 1 and group 2. So we have the mean for those two groups. That comes from right here. We have 26 students in each of our groups. What I want you to notice is the standard deviation is different between these two groups. So that means that these are not distributed in the same shape, or they're not distributed with the same skewness. And this one may have a negative skewness to it, or there's something about the shape that's not okay. That's not, and remember we said that we want normal distributions. This isn't necessarily the end of the world when this happens. So I want to show you what can occur when we get uneven distributions. So this is the descriptive data that we're all familiar with. This is the actual output from a t-test. So the first thing it's going to do is it's going to run a test for equal variances, and it is going to determine the extent to which this data looks like this data in terms of its shape and distribution. Kind of suspect there's something wrong because of that. So really at this point what you need to know is they need to be the same shape. If this number right here is greater than 0.05, then we stay on this line to make our decision. And what that means is that it has equal variances. If this number is smaller than 0.05, then we can assume that these shapes are different. It's not the end of the world, we just have to use this data. So here's what's happening is the computer is using this data to make a decision. And it's going to allow all but one of these numbers to fluctuate. So it's going to allow 25 of these scores to fluctuate and 25 of these. So if you put those two together and subtract one of them, you get 50. So the degrees of freedom that it's actually using to make its calculation has been adjusted to 45.028. Now, that being said, the next decision we have to make is there a significant difference between this and this? Because this number, now this is the actual t-test number, is not less than 0.05, then what we would say is these two sets of data are statistically equal. So here's the average difference between those two, and if you were to take 81.65 and subtract 78.84, this is the number you get. Here's the confidence level of the differences. And what you'll learn later on is when there's a positive and a negative here, or vice versa, you're not going to have a significant difference. There's too much overlap between the two numbers. Let's look at another example. So here, and this was an experimental group and control group, but it's okay for what we're doing. We have the mean for this group, and we're going to call this one the number 1 experimental. So that's 81. And the other group, group 2, is 51.61. Standard deviation. And for the other group is 12.6. So what we'll notice now is these standard deviations are pretty close to one another. We go down here and we check the Levene's test for equality of difference. We notice that this number, not only is it greater than 0.05, it is much greater than 0.05. So we can stay on this line to make our decision. So we discovered that there is a significant difference between these two groups. The difference between those, if you subtract these two numbers, is that number right there. And you'll also notice, as I said in this case, the upper and lower bounds of the confidence intervals are the same indicators, both positive numbers. If you want to look at where the data comes from, this is the first one where there wasn't a difference. This is the second one where there was a difference. So if you were just to kind of glance at those, looking across these, they're really not that much difference. There's just a few digits that are higher in this group that are causing the change we see. So you can't always depend on averages. You really need to depend upon some other sort of test to be able to determine that. And that's what a t-test does.